Hello, I'm Frank Bailey, Director of Operations for BRP here at Sturtevant, Wisconsin. We're going to take a few moments to show you how we bring our evinrude E-Techs to life and introduce a couple of our experts along the way.
The evinrude manufacturing process starts with the building of the power behind the outboard, its engine.
Hi, I'm Dave Regenauer. I'm the area coordinator for the machining department here at BRP in Sturtevant. We're in front of the Eagle Rail, what we call the Eagle Rail. This is where we machine the blocks for the outboard engines, two-cylinder, all the way up to the big V6s. You see one of the pallets bringing a block onto the fixture, onto the vehicle. That'll deliver it to the machine. We run every product every day. Immediately after that, and all blocks get the same process, we press the sleeves in, and we do them all from the two-cylinder up to the big one. So this is our final machining operation, which is to hone the cylinder bores. We size them to our finished size, and we create the crosshatch, which gives the surface finish for oil retention.
Now we're at the beginning of our powerhead build line. Now the machining is on its way and the lower units are nearly done. We start building a powerhead down this line. So these are computer-controlled torquing devices, and essentially what this allows us to do is to control the speed. We bring the screw down, and then also make sure that as it's torquing up, we know exactly the torque angle, and we can get all the clamp load there is in that fastener out of it before we damage it, and we stop right there. So here we are at the beginning of what we call our dress line. At this point now, the rotating assembly is all put together, and on the signal we need to match the lower unit that's coming to us. They'll start this operation down the line. We put on all the electronic controls, the fuel system. By the time we get to the end of this line, it's a motor ready to run.
With the engine built, we can turn our attention to the wheels of the outboard, the propeller assembly. Pre-built at another facility, the propeller unit begins the process with a coat of primer.
Hi, my name's Rick Stimps. We're here at BRP. I'm the production supervisor for the paint area here. Right now we are looking at where the units go into paint and primer. The primer area basically is the start of our 4-hour lag time process. We'll put in a coat of epoxy primer on them, and what we do here is we actually color code them. So any of our lighter colored motors get a lighter color primer, darker motor gets a darker color primer. If they do happen to have a scratch or anything on that unit, it's not as easy to see because they do color match a little bit better than if we were to use a standard color across the board. After we put the epoxy primer on, it goes through a quick flash off, then it's going to hit an oven at about 225 degrees and it's going to bake out. The one behind me here coming out of the oven you see is actually done in our black primer, which means this one's going to be probably a blue unit. After it comes out of here, we are going to look at that one more time through a final inspection. If there's any type of defect in that primer surface, they're going to fix that before it goes on for the final coat. Pretty much the same process as you see in the primer booth. They're going to have a guy undercoating them with an electrostatic gun, top coating with a conventional gun, make sure that we're getting all that surface covered the way it should be for a long life in the field. After all our units come out of the final paint booth, they're going to come out here. We're going to take a look at them. Every single individual unit gets inspected. At this point, they basically get a barcode on them that says this is a good unit, and we send them on to the next department. It's going to meet up with the powerhead that was started on another line.
Now here we are at what we call powerhead set. At this point, the operator is given a request by our control system. Our computer system says, hey, this is the next model you should be making. So the operator will scan the powerhead, scan the lower unit to make sure they're a legitimate match and something that a customer is asking for. And then we actually set that powerhead on the lower unit. So the two parts of the plant are once again tied together, and this motor is on its way to test.
With evinrude's top-of-the-line design and innovative technology, means your outboard motor requires no break-in period and is ready to use right out of the box. But long before an outboard goes into production, Evinrude does extensive testing to make sure the engines used by FLW anglers meet the highest standards.
I'm Jeff Wassel. I work in the emissions testing lab. I'm responsible for all engine certification work. What we have to do here before we can actually market an engine, what we do is a certification test, and we're looking for things such as hydrocarbons, nitrogen oxides, carbon monoxide, carbon dioxide. Those are some of the gases that we're regulated on. And what we need to do is we need to run the engine in a test cell. So we've got this happens to be a 150 horsepower Evinrude E-Tech on the dyno. What we're really interested in is the exhaust emissions coming out of the engine itself. So what we've got here is a probe here located at the base of the power head. And this is taking a small sample of exhaust from the base of the power head. So this is before any water gets mixed with exhaust. It flows through this heated line up through a heated filter and into a 5-gas emission bench. One of the things with the evinrude E-Tech is we've made this engine comply with all of the most stringent standards, not only for US EPA but California Air Resources Board. We were the first two-stroke direct fuel injecting engine to be allowed on the Bodensee, which is a lake that's surrounded by Germany, Austria, and Switzerland. So it really goes to show how clean this engine technology is.
Now we're in final test, so every motor we put together in this facility comes through this operation. So everything gets 100% tested. We use a standard propeller and a normal test tank with about 7 tons of water there, and we use a prompt and response system. So the operator scans the motor, says this is the motor I'm testing, and the computer prompts the operator to set up the test parameters and check every feature. By the time we're done with this test, we will have checked a whole host of parameters, from idle quality to oil flow, airflow, fuel flow, water pressures, temperatures, RPMs, alternator up with the whole smack. If it's not exactly what's expected, we send it to repair to check it. So here we are at the end of our, what we call our shine line. It's where we've putting the finishing touches on the motors. All of these have passed our rigorous tests, and at this point they're on the way to our customers for more time on the water.